All right, 3-1, graphing polynomial functions. I'm going to write some stuff down here. It's part of your notes. Degree of a polynomial is the degree of the first term when written in standard form. All right. Leading coefficient, we often call that A. It's called A. And anyways, it's the coefficient in front of the leading term when written in, guess what? Standard form. All right, a polynomial function. Now, the word poly means many. So a polynomial means means many. So a polynomial is the sum of many monomials. That's all she is. A relative maximum is a high point on a graph. Relative minimum would be a low point on a graph. And the standard form of a polynomial, and I'll just give you an example of a cubic. Say we have 3x to the third plus, I don't know, plus 4x to the second, and then just say minus 3. You'll notice that exponents are written in decreasing order. All right, 3, 2, nothing, then the 3. Turning point is simply where a graph turns. That's all it is. It's where a graph turns from decreasing to increasing or vice versa. All right, there's your vocab. All right, essential question. How do the key features of polynomial function help you sketch its graph? How can you write a polynomial in standard form and use it to identify the leading coefficient, the degree, and the number of terms? So let's take this thing and put it in standard form. I wish they would have given it a name. But in standard form, the 2x cubed would be the first thing you'd see. And that's part of it. Some kids, for the life of them, can't write things in standard form, but that's what she looks like in standard form. All right. Now, the standard form shows any like terms combined and the terms by degree in descending numerical order. And I've already done this one. Standard form of that polynomial is as follows. And they have a little note here. Note there is no x squared in that polynomial. In some cases, it may be useful to write in the 0, and we will talk about those cases. We're going to do something called synthetic division and long division, where that's extremely important. All right, so here we have a try it. What is each polynomial in standard form, and what are the leading coefficient, degree, and number of terms of each? All right, so hopefully standard form is not a problem. Let's look at A. First term is the negative 5x cubed. Signs matter. And then I see a minus 3x to the fourth. And then plus a 2x, and then plus a 6. Now, the leading coefficient, which again we call A, is equal to negative 5. The degree of the polynomial, all you need to do is look at this guy right here, the first piece when you're in standard form, is 3. And we call third degree polynomials, I used to think some of this stuff was known, but we call them cubics. That's what we call them. We call them cubics. All right. Next up is B. B is not in standard form. It's 2x to the 6th. Looks like plus an x to the 5th. Minus 3x to the 4th. We got next plus 4x to the 3rd. Minus 8x. Usually, the only thing that's actually named, as far as I know, that's commonly used is up to the 4th power, which we call a quartic. But we don't name like a 6th degree polynomial. I've never seen it done. But our leading coefficient is going to be 2, and the degree of the polynomial is a sixth degree. We don't have a specific name for 6 degrees that I'm aware of. I'm sure there's one out there. It's just not common. So we're not going to talk about it. All right, so you'll go back to this question here. How can you write a polynomial, use it to identify? Oops, that wasn't it. The key question was, how do key features enable you to sketch a graph? So we're about to do some review content. It's called end behavior. And this was on a couple of quizzes first 6 weeks. End behavior is how a polynomial behaves, its output or its y values, for very small, which means negative infinity, and very large, positive infinity values of x. So we've already been over this stuff, believe it or not. Here we have a positive x to the even, and you may or may not recall that it starts at stay high and it ends at stay high. Our example here is a quadratic. The parabola starts high, ends high. Now, as x approaches, a lot of y'all didn't like this part of it, negative infinity, y rises to positive infinity. And as x runs right towards infinity, y also rises towards infinity. I taught all that stuff to you early on in preparation for this unit, just so maybe you'd remember it. All right, what happens if we still have an even exponent, but we have a negative out front? That causes a vertical reflection. Remember, the negative is the vertical reflection? Well, now as x runs left towards negative infinity, y is falling to negative infinity. And as x runs right to infinity, y is also still falling towards negative infinity. And there's your x to the evens, whether positive or negative. Here we have x to the n, where n is odd. The odd ones start their day low and they end their day high. That's just how they work. An example of this would be like x cubed. And I know you may or may not believe me because you've probably never seen a cubic function graphed, but I made you all memorize them. Maybe you don't remember that, maybe you don't, but just to prove to you I wasn't making something up, here's what x cubed looks like. Oop, I forgot to do zoom 6. Starts low, ends high. Okay? So as x runs left to negative infinity, y falls to negative infinity. As x runs right towards positive infinity, y rises towards infinity. Negative x to the n, where n is odd, this would be like a negative x cubed, would start its day high and end its day low. So now as x runs to negative infinity, y is rising to infinity, and as x runs right to infinity, y is falling towards negative infinity. Moving forward, I'm trying to keep this quick for you. Use the leading coefficient and the degree of the polynomial function to determine the end behavior of each graph. And we often call these things other things. It's often also called a power function because it determines the overall behavior of the graph. The small pieces, they work near the origin, but the first piece trumps the overall grand scheme of things. But anyways, I noticed that 2x to the 6th, this is an x to the even, isn't it? And it's specifically, it's a positive x to the even. So I would expect it to behave like this. That's the end behavior, all right? This guy is not in STD form. Negative 5x cubed plus 8x plus 4 would be standard form. And the piece that I care about is that guy. And that guy is a negative x to the odd. And all negative x to the odds start their day high and end their day low. And again, hopefully this is a review for you. Pause BRB. So I know that about half of you know this formula, but average rate of change is f of b minus f of a, sitting pretty over b minus a. And we get a and b from the given intervals. So let's just plug in the numbers of the formula first, then we'll go back and find it. Maybe that'll help some of y'all figure it out. I need to figure out what f of 0 is. I'm supposed to take away f of negative 2, and that's going to be sitting over 0 minus a negative 2, which, by the way, is 2. Now, you're going to have to figure out what f of 0 and f of 2 and negative 2 are. To find f of 0, every single x you see becomes a 0. This literally says x equals 0. That's what it says, bruh. But I don't know. I don't know what goes on through your heads. Math is about memorization. And you would get back a 2, I think, right? that looks like a 2. 0, 0, 2. So that's a 0. We're supposed to take away f of negative 2. And again, if I want to find f of negative 2, it literally says let x be negative 2. So let's see what we get here. We get negative 0.5 of a negative 2 to the 4th plus 3 times a negative 2 plus a 2. Now, I'm going to do some stuff by hand, okay? But feel free to just push buttons. I'm not judging you out loud. If you take a negative 2 and you multiply it by itself 4 times, you're going to have a positive 16. There is a negative 0.5 that's saying cut it in half, make it negative. This is negative 8. This is negative 6, and that's plus 2. And you got 8 minus 6, which is negative 14. You add 2 back, and you have a negative 12. Careful on your signs. This is 0. Take away a negative 12. That's a positive 12 sitting pretty over 2. And you get 6. It's worth doing this with you as well. In addition to pushing buttons, the TI-84 is extremely powerful. I'm going to go to y equals here and show you a couple of things. I'm going to take negative 0.5x, raise it to the 4th power. I don't know how many of you guys will actually do this. Most of you probably won't. It's like you're terrified of a graphing calculator. You are. And then I'm going to do what I taught you to do, which is a zoom 6. Now, it's got some skill level. Like, I'm not going to see certain things, which is part of the problem. But I think the calculator can do it anyways. Here's the graph of this thing. And by the way, talking about end behavior, that was a negative x to the even, wasn't it? Low, low? I believe she was. Anyways, so if you can figure this out and you have a graph in front of you, check this out. Second trace. I want to know the value of x when it's 0. So I'm literally going to go to value and type in a 0. And by God, it gave me a 2. Let's do this again. I also want to know the value of y when x was negative 2. So I'm going to let x be negative, not 3, negative 2. And apparently it's saying I made a mistake, because it gave me a 6. Where did I mess up at? Did I type it in right? Oh, I see it. I was supposed to square that thing, wasn't I? I'm glad I checked this. I am. That's 4 times 3, which is 12. Maybe I should have pushed buttons. So we have negative 8 plus 12, which is 4, plus 2, which is 6. Aren't we glad we checked it out with a calculator? Little things, always little things. And I got a 6. So, scratch this. I should have 0. Boy, I really broke this thing, didn't I? Good God, man. I should have 2 minus 6 sitting pretty over 2. I should have negative 4 over 2. Thank God I checked myself in a TI-84. Thank the Lord. And, my graph does not suggest an average rate of change of 6 either. Anyways, there you go. Glad I caught it. Sorry if that messed you up. All right. The graph shows the function, and I changed this so you'd have to graph it. I want you to graph x to the 4th plus 2x cubed minus 13x squared minus 14x plus 24, and I want you to draw a rough graph here. So let's go to y equals x to the 4th plus 2x to the 3rd. A little disappointed your book doesn't go into a very good definition of what a polynomial really is. But they dumbed down Algebra 2. They really have. They really, really have. This course is but a fraction of what it used to be. It used to be a really intense course. I know some of you are like, it used to be? Oh yeah, Algebra 2 used to be about 5 times worse. Anywho, you zoom 6 this bad boy. And I'm going to have to play with the window some, I think. See a good picture here. You say I have this plus 24 and you're seeing dips and dives. I'm going to go to window whenever my calculator is done. I'm going to set a y max of let's say 28 and a y min of negative 28 because I want a good picture. And I'm going to hit the graph key. And I think this will give me a pretty good picture here. And it did. It really did. So I'm going to label some things about this thing that I know are true. And, you know, we can use a TI-84, by the way, to help us figure out some of these things. Like if you can't figure out that the x-intercept here is at -4, you can always hit second trace, go to 0 because x-intercepts are called zeros. And what we're going to do is we're going to take our little cursor. I'm going to keep pressing that left arrow until I get left of the 0. See how it wants a left boundary? Press enter. Right of a 0, enter, enter for a guess. And it's -4. But it's worth going ahead and plotting those things out because I do ask for the x-intercepts. There's one at -4, 0. There's one at -2, 0. You know, I grade your basics quizzes. It's sad to say this, but not every junior can pick out an x-intercept. Like that's really, really hard. Like, I don't get it. I don't understand how we have made it to our junior year of high school and we can't pick out an x-intercept. So there's your x-intercepts. It does not ask for a y-intercept. It's kind of a shame. It should. But anyways, number of terms here is simple. 1, 2, 3, 4, 5. Remember, poly means many. The degree, it's the fourth degree. And we call that a quartic. We don't call it a quadrant, we call it a quartic. Leading coefficient is 1. The end behavior, it's functioning just like an x to the even would be. So as x approaches -infinity, y approaches infinity. And as x approaches infinity, the graph rises to infinity. Specifically, it's behaving like a positive x to the even. That's what it's doing. Turning points, it has 1, 2, 3. 3 turning points. That's where the graph changes from decreasing to increasing or vice versa. The relative minimums are these 2 points right here. Minimums or maximums also tend to be turning points. And let's just use our calculator to figure these out. Check this out. Second trace, go to minimum. Works the same kind of as that 0 function. You get left of a minimum and you press enter. You get right of a minimum and you press enter, and then you press enter for a guess. And there she is. And the only thing I actually want back is the y value. I don't want the x value. It's -25. And I can guarantee you this one's the same. Well, I shouldn't say that, but I see a heck of a lot of symmetry on this graph. But let's just double check me because I've already made one mistake in this video. But I do see a heck of a lot of symmetry. So now I'm going after the other minimum. Notice I'm holding that right cursor down. I got left and pressed enter. I'm getting right and pressing enter. And I'm doing enter for a guess. And it was also -25. Next thing this wants is a relative maximum. Second trace 4 for max. Works on the left boundary, right boundary idea. So left, because that's what it wants, press enter. Right boundary, get right of the max, press enter. And enter for a guess. And it's kind of funky. It's 27.5625, which I want to say it's like 27 5/8, but it's not. But 27.5625. And again, this is also a minimum. This is also a maximum. That's what they are. Intervals where the graph is increasing. So as I grade your basics quizzes, I happen to notice that only about 30% of my students can tell me where a graph is increasing or decreasing. I'm increasing here to here and there to there, okay? Now, I probably should have wrote down this x value over here, and I probably should have wrote down one down over there. I'll fix that real quick. Second trace 3 for minimum. And I should have wrote down that one up there too. Left, right, enter. So negative 3.1926. The y value of negative 25. I feel like I'm probably just going to be, well, I'm not going to say what I was thinking. I think it was wrong. But I should see some symmetry in that decimal. Or it might be that decimal taken away from 1. Anyways, I just did the whole left bound, right bound thing. Yeah, 2.1925 again. And again, negative 25. Now, I also happen to need this third key point up here, that maximum. And I should have, if I'd have been thinking properly, wrote those numbers down, but I did not. Left, enter. Right, enter, enter for a guess. Now, that's a rounding error right there. That's negative 1/2 and 27.5625. So, and the hard part about these is the x values is what we're after. I am increasing from negative 3.1925 all the way to negative 1/2. And also from 2.1925 as I move right towards infinity. I'm talking about x values. Good stuff there. Decreasing while I'm at it would be those paths. I am decreasing from negative infinity all the way until I run into this x value of negative 3.1925. And I'm also decreasing from an x value of negative 1/2 until I get to 2.1925. All right, so, I talk about the basics quizzes. I use the basics quizzes as diagnostics on students mainly. I'm trying to figure out what you know and what you don't. Positive, positive, positive. Above x-axis. That's what that means. Above x-axis. Also written as where is f of x bigger than 0. I am positive from negative infinity until I hit negative 4. Union with negative 2 to 1. Union with 2 to infinity. And it's the same thing. I'm talking about the x values that make this true. Next up is negativity. I thought I changed colors there. I am negative so long as x is stuck between negative 4 and 2. And also so long as x is stuck between 1 and 3. So continuing where I left off yesterday afternoon, sketching based on behavior. So here we are told that f of x is positive from negative 8 to negative 4, and that means above x-axis. And here we're told we're negative from negative 4 to negative 1. That's below the x-axis. These simple ideas here. And from 4 to infinity. So what happens here? We're above the x-axis from negative to infinity to negative 4, and we're below from negative 4 to negative 1. So we're coming in from up high, and we're actually crossing. All right, that's a crossing. We're also positive from negative 1 to 4. And negative here. So from negative 1 to 4, and 4 to infinity. Those are crossing points they're telling us about. It says we are decreasing from negative infinity all the way to negative 2.67. So decreasing means downhill. So about right there. And from 2 to infinity. All right. Increasing from negative 2.67 to 2. So a turn has happened. That's a turning point. And that does it. There's a rough graph of that polynomial based on behaviors that were told to us. It's a higher level skill. Not everybody's going to be able to do it. You know, the goal is to make STEM majors here, kids. All right, interpret a polynomial model. In a science class, Abby mixes a fixed amount of baking soda with different amounts of vinegar in a bottle capped by a balloon. This will release gas. The balloon will inflate. She records the amount of time it takes gases produced by the reaction to inflate the balloon. From her data, Abby created a function to model the situation. Abby's a pretty bright girl. For x quarter cups of vinegar, it takes t of x, I'm assuming t is time, equals negative 12 hundredths of x squared plus x squared minus 3 and 38 hundredths x plus 13 and 16 hundredths of a second to the balloon. Probably missing the word inflate there. Yeah, there it is. It's over there. To inflate the balloon. How long would it take to inflate the balloon with 5 quarter cups of sugar? So they tell you in the text, and that's really all this is about. It's about reading comprehension, that x is quarter cups. So the time of 5 quarter cups is just found by plugging things in. Nothing more. But of course, I know some of us struggle with the reading aspects. It's funny as a teacher, you'll watch kids write this and then they just stare at it. Like, kid, you wrote it down, go to your TI-84, push some buttons, and move on to the next problem. You don't know how to cube a number, hit that rooftop key and then the 3. I'll show you how to do this in a graph too. But, you know, some kids think that, well, anyways, there's more to it. It looks like it's about 6.26 seconds. Now, they want us to sketch the graph anyways. It says use technology. So, obviously, push buttons in TI-84. Play along, kids. You're supposed to play along. But some of you won't even bother doing this. Somebody could tell me how to cure apathy. Things would be a lot better. All right, so I think I've got everything typed in correctly. Zoom 6 is what I always want you to do. Something interesting happens after a while. Time hits negative. The graph seems to make sense. This was, if you'll notice here, it was x cubed. Think about your x to the odd. X to the odd starts low, ends high. This is a negative x to the odd. Starts high, ends low. And you'll notice what's happening is there's a point where you don't produce any gas because you've just added too much vinegar, right? That's the whole point. The chemical reaction doesn't happen. And if I want to know on a calculator, because you can use a TI-84 to just punch in numbers. That was 5 quarter cups, right? Second calc value when x is 5. 6.26. It's just kind of a cool feature that the calculator does. All right. What do the x and y intercepts of the graph mean for this context? Do these values make sense? Probably not. The y-intercept here, of course, we find a y-intercept by letting x be 0. So we would have t of 0, which is the y-intercept, negative 0.120 cubed plus 0 squared. I actually hate writing this down, but I have to because so many kids don't understand. All you're going to have left is 13.16. And this would be seconds to inflate the balloon. Now, I don't think it makes any sense because a chemical reaction has not happened yet. Has it? You haven't added any baking soda. So, you know, the y-intercept does not make sense. Because no baking soda has been added to start chemical reaction. I've been around vinegar. I'd be highly surprised if vinegar on its own right would actually cause anything. Now, your x-intercepts, we're just going to use our technology here. Oh, by the way, using technology, if I would have looked up on my window to about 30, you know, you saw me write everything out the classic way, the things we're supposed to know how to do. I would have actually been able to see the y-intercept. And if you can see it happen, you could count tick marks, or, and hear me out, you could hit second trace value and let x be 0. But you still had to remember that x was 0. And you got your 13.16 seconds. Now here's your x-intercept. Second trace, we'll use the 0 function. You're going to get your cursor close to the 0. Press enter. You're going to get your cursor to the right of the 0. Press enter and enter for a guess. Your x-intercept's at 6.585. So just say roughly 6.589 seconds. I'm sorry, it's not seconds. 6.590. And this says that 6.59 cups added. And the balloon does not inflate. That makes sense to me. There was too much vinegar. No chemical reaction. Anyways, there you go. Oh, by the way, the reason I'm saying the balloon does not inflate is because the y value is the time it takes to inflate the balloon. So the balloon never inflated, or it inflated simultaneously. Actually, let's think about this. It was a spontaneous inflation, is what that would be saying. And look at some of this stuff down here. That's negative time. And this stuff over here is negative cups of vinegar added. So interesting things about that graph. All right, we got to try it here. It's the last one to do. Danielle is engineering a new brand of shoes. For X shoes sold in thousands, a profit P of X is given as negative 3x to the fourth plus 4x cubed minus 2x squared plus 5x plus $10 in 10,000s will be earned. How much will be earned in a profit for selling 1,000 shoes? So, key things in this text. For shoes sold, X shoes sold in thousands. This is saying that X is 1. Because 1,000 shoes is 1,000, right? All right. So if I want to know that result, I'm literally just going to plug in a 1. The profit for selling 1,000 shoes is negative 3 times a 1 to the fourth plus 4 times a 1 cubed minus 2 times a 1 squared plus 5 times a 1 plus a 10. So this is going to create a negative 3. That's going to create a 4. I hope you know that 1 to the fourth is 1. That's going to be minus 2. These two numbers is 15. And what do we have here? We have a negative 5 plus 4, which is negative 1, plus 15, which is 14. And that is dollars in 10,000, so $14,000. Now, according to the graph, I'm not graphing this polynomial by hand, is by and large out of the scope of Algebra 2. So we just cheat with the TI-84. Now, we are going to be learning behaviors of graphs. There's a lot of stuff about graphs that you learn. When you learn how to freehand most graphs, they're not meant to be perfect. They're meant for you to have an understanding of what's going on. Not that you care. Just letting you know what's coming. Zoom 6 the way I trained you. And we should see a graph. But we don't see the whole picture. I want you to note that this is asking about the maximum profit. And I don't see that on my graph. So I'm going to go to Window. I'm going to look up, say 20. Oops, wrong place. X max of 20. Hit graph. Now remember, X is shoes, Y is profit. Remember that. X is shoes sold, Y is profit. Okay. Now that's a maximum right there. Second, trace 4. Maximum. Works on left and right boundaries. So get left of the maximum, press enter, then get somewhere to the right of the maximum, press enter, and enter for guess. And we got 1.0574. Now, the reason I went on the rounding so far is because I have to shift the decimal. According to the graph, what quantity of shoes sold produces the maximum profit? Remember, X is in thousands. So just take your decimal and shift it to the right 1, 2, 3. And I get 1,057 shoes. That maximizes profit. Okay? What is the maximum profit? Well, that would be the Y value. And that's in 10,000s, 14.02945. Lost my place there. 02945. Remember, that's in 10,000s. So we're going to shift that decimal 1, 2, 3, 4. $140,294.50. I did this one wrong. That was 14 times 10,000, wasn't it? There we go. All right. What do the x and y intercepts of the graph mean in this context? Well, the y-intercept is the profit when 0 shoes are sold. Now, according to the graph, there's profit when we don't sell any shoes. Look at it. I'm going to let x be 0. Remember that? According to the graph, y is 10, which means a profit of $100,000. And that's complete nonsense. 100% nonsense. Doesn't make a lick of sense, does it? All right, your x-intercept looks like it's at 2. And it probably does make some sense. Let's double check to make it 2. I'm using the 0 function. I hit second, trace 0. Left, right, enter. Yeah, okay, it's 1.9146. Which means that, and it probably does make sense. Which would be what, 1,900, and we'll say 15 shoes. There's no profit. And that's probably reasonable because what's happened is you've probably made too many shoes and you have to discount the price. So I think this one is okay. I do. That one's okay. But the y-intercept, garbage, complete garbage. And oftentimes y-intercepts are. All right, that's it. Hope you enjoyed. Anyways, see you Monday. All right, I got 3 to go. A verbal sketching a graph from a verbal description. How can you sketch a graph of the polynomial f from a verbal description? Higher level thought here, and that's kind of the goal, believe it or not, is to get you up to a higher level. Actually, I think I'm going to just stop for the day and finish this in the morning. I'll blend the videos tomorrow.